All right, so we're going to go ahead and talk about the second Fourier response question from the 10.10 homework, okay? Here's what we're looking at. The Maclaurin series for a function f is given by this series, and we have some of the terms written out in the general term over here. And we know it converges for the absolute value of x is less than r, where r is the radius of convergence for the Maclaurin series. Maclaurin series, again, a Taylor series centered about x equals 0, right? A says use the ratio test. We know that. Use the ratio test to find r. R is the radius of convergence. And we've seen before how we can use the ratio test to determine that radius of convergence. All right, radius of convergence. Let's do it. Ratio test. All right, for our ratio test, we need to find the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n, right? All right, let's go up to our series. We have our a sub n terms. They are right here. A sub n, or the general term, these are the same, right? So a sub n plus 1, so I need the limit as n approaches infinity, absolute value of a sub n plus 1. So let me replace all my n's with n plus 1s. So that'll give me -3 to the n minus 1 plus 1, because it's n plus 1 minus 1. So that'll give me -3 to the n over n plus 1, because remember, I'm replacing every n with n plus 1, x to the n plus 1. Okay. But then I need to divide this by a sub n. A sub n is this up here, our general term, but dividing by same thing as multiplying by the reciprocal. So I'm going to say times n over -3 to the n minus 1 x to the n. Because really this x to the n is, you can think of it as a numerator thing, right? So there we go. All right, that is what I need to find the limit of the absolute value of all that. Okay, so let me go ahead and do my simplifying. Let's see what this gives me. The limit as n approaches infinity of the absolute value of, okay, -3 to the n, -3 to the n minus 1. So I'm going to be left with -3 to the n minus 1 still down there, right? So I will lose my -3 to the n. I will also, if I come over here, x to the n plus 1, x to the n, I'll lose the x to the n's, but have x to the 1 up top. So this will be x to the first power n, because my n and my n plus 1 aren't going to cancel out. My x to the n plus 1 will cancel out with the x to the n, but leave it x to the first power up top. N will be left up top. -3 to the n will cancel out with a lot of stuff down here, but leave -3 to the first power down there. And I'll still have my n plus 1 down there. Sorry, -3 to the negative first power, because n go up to the negative first power. All right. This is looking kind of interesting. I can keep making this at least a little nicer to look at. -3 to the first power, I could flip it to the numerator, so that would give me, if I rearrange a little bit, -3 to the first power up here by moving that to the top, because it's a negative exponent. Nx over n plus 1. So what does this mean for me? The -3, because of this absolute value sign, doesn't really matter, but the x could be, the absolute value sign for this -3 will make it positive, but this x is a variable, so I don't know it. So I got to keep track of my absolute value signs at least there. So let me write it out this way. The limit as n approaches infinity of, let's call it 3n absolute value of x. Notice I brought the n out of the absolute value sign too, because n is going to infinity, so it's always going to be positive, over n plus 1. Because really, the absolute value sign got rid of that negative, but we'll need to still apply it to x, because it could be positive or negative, but n is going to stay positive. So what is this limit for us? As n approaches infinity, n and n are going to grow the same power. We have 3n over n. The plus 1 is not really going to matter. So then this n behavior model limit would be something like, as n approaches infinity, equal to my n's are going to be what's important over n, but that will simplify, if I'm thinking about how these things grow, into 3 absolute value of x as my limit, right? And if my ratio test is going to have something converge, I need this limit to be less than 1. So what does that mean? That means the absolute value of x has to be less than, I'm going to divide 3 to the other side. Nope. I guess I could actually get rid of that, that limit now, because as n goes to infinity, the n's divide away and we kind of lost them. So we just have the absolute value of x is less than 1. So absolute value of x has to be less than 1/3, right? Absolute value of x has to be less than 1/3. This then can tell us about our radius of convergence. X can be kind of plus or minus 1/3. We'd have to check the endpoints if we wanted the interval, but the radius then on either side of x, of either side of 0, I mean, the radius of convergence is going to be 1/3. All right. So you get 1 point for setting up the ratio. You get 1 point for computing the limit of the ratio, which we found down here. And then we got 1 point for determining the radius of convergence. Okay. Let's take a look at the next part. Part B. Part B says, write the first 4 non-zero terms of the Maclaurin series for f prime. Okay, well, what do I know about f? F of x, I know, is given by the series x minus 3 halves x squared plus 3x cubed, right? And we could keep going here. In fact, we probably should. The next one in our term will be minus. We want to follow this, so we did the n is 1, n is 2, n is 3. We now need when n is 4. When n is 4, up here, we have a negative 3 to the 3rd power. Oop, sorry. I made so this is 1, when n is 2, when n is 3, when n is 4. Got lost for a second there. My next term then will be negative 3 to the, 3rd power, x to the 4th power, because n is now 4. Notice our series started at 1, so n is 1, 2, 3, 4, over 4, plus so on and so forth, right? So there is my f series. I want the derivative of that, so I can do term by term differentiation. This will give me 1 minus, take the derivative there, 3x, plus, take the derivative there, 9x squared. Take the derivative here, the 4's will cancel out. That'll give me, let's see, 3 cubed is 27, so that'll be minus 27x cubed, plus so on and so forth, right? So here are the first 4 non-zero terms of the derivative of f. Now we want to express this derivative as a rational function. Now here's the thing. I can recognize here, it seems like every time I step up, right? Every time I step up a step here, I'm multiplying by negative 3x. 1 times negative 3x will give me negative 3x. Negative 3x times negative 3x will give me 9x squared, and so on and so forth. So this, to me, looks like a geometric series. And what do we know about geometric series? Well, I know geometric series, if it's going to converge, then that means the sum is going to be equal to a over 1 minus r, where r is the thing I multiply by, the ratio I'm multiplying by each time, right? So if this is a geometric series, we are multiplying by the same thing each time, we can use this. This means this series, the sum of all this stuff, then f prime of x, is going to be equal to a, my first term, which is just 1, over 1 minus r, whatever I'm multiplying by each time to step up my terms, which is negative 3x. All right? Which I can simplify and say, hey, that means f prime is equal to 1 plus 3x. This series is going to sum up to 1 over, 1's my initial term, 1 over 1 plus 3x, because minus 3x was my ratio I'm multiplying by each time. So in the interval of convergence, this is going to be my series. the derivative of f is equal to 1 over 1 plus 3x. So you get 2 points for your first 4 non-zero terms. 2 points for your first 4 non-zero terms. And then the final point is for the rational function down here. All right. And we can move on to part C. All right, part C says, right, the first 4 non-zero terms of the Maclaurin series for e to the x. This is why it's important to memorize those Maclaurin series that you'll have a quiz on Thursday. All right, what are our first terms for e to the x? E to the x is equal to 1 plus x squared over 2 factorial. It's one of our easier ones to remember, plus x cubed over 3 factorial plus, and so on and so forth, right? I guess probably the better, more accurate math thing to say would be that e to the x is going to be approximately these things, because they just want the first 4 terms there. Okay, e to the x is approximately that. Here's the first 4 non-zero terms of the Maclaurin series for e to the x. All right, now use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g of x, which they're saying is e to the x times f of x. Okay, e to the x times f of x. What's that even going to look like? Well, e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. That's what I'm going to sort of start off with for e to the x, and it's going to be times f of x. What do we know about f of x? F of x, its terms are listed up here, right? X minus 3 halves x squared plus 3x cubed. I'm just going to leave it there, and we'll talk about why here in a second. All right, so that's what I'm multiplying by, e to the x times f of x. And I stopped there because I only want the third degree Taylor polynomial. So I need to stop where I get third degree powers here, because anything times those is either going to be third degree or less. So I'm going to stop at the third degree there. Now let me think about how these things actually multiply together. Well, this 1, as it foils in here, 1, I want to stay at third degree or below. 1 will multiply in and will be fine all the way through. I'll be at third degree or below. So 1 times x, 1 times minus 3 halves x squared, 1 times 3x cubed, that's fine. So e to the x times f of x is going to be approximately equal to 1 times all of these is fine, so I'm just going to write them all down. X minus 3 halves x squared plus 3x cubed. Now let's see what happens when we FOIL x in. X, when it FOILs in, will be x times x, which will give me plus x squared. X times negative 3 halves x cubed will be minus negative 3 halves x squared will give us minus 3 halves x cubed. And that's actually where, like, I got to stop, right? I got to stop there, because if I multiply x times the next thing, I'll be above a third degree. Right, so let me look at my next term, x squared over 2 factorial. X squared over 2 factorial times x will give me x cubed over 2 factorial. X squared over 2 factorial can't multiply these other two guys, because that'll give me powers of 4 and 5, which is more than third degree. And x cubed over 3 factorial, it actually can't multiply anything and still be at third degree, because it'll be at the 4th degree, 5th, 6th, and so on. All right, so this is actually where I want to stop for writing this. I just need to sort of consolidate things and write out what I got. So what does this mean? This is g of x, remember? G of x. And so that means for us, g of x is approximately x. Let's combine some like terms. X has no like term partners. So I'll come in here and say then x partners for squared. So this is negative 3 halves x squared. This is positive 1 x squared. So negative 3 halves plus 1 will give us minus half x squared. This is 3x cubed minus 3 halves x cubed plus 2 factorial 2, so x cubed over 2. So negative 3 halves x cubed plus 1 half x cubed will give me minus x cubed. This will give me 3x cubed minus x cubed. Combining those will give us plus 2x cubed. If you need to, just write out, bring over, kind of come over here on the side, right? Really what we have is 3 minus 3 halves plus half as our coefficients for our cubed things, which is going to take us to 2. Okay, so this is what it looks like for g, x minus half x squared plus 2x cubed plus, and it would keep going, right? I want the third degree Taylor polynomial, right? That means the third degree Taylor polynomial t sub 3 of x is going to be equal to x minus half x squared plus 2x cubed, all right? This is my third degree Taylor polynomial. Point-wise, how does this break down? You get 1 point for your first 4 non-zero terms for e to the x. You just get 1 point for doing this. And then 2 points for your final Taylor polynomial down here. All right. Cool. Hope that helps. Please make sure you check the scoring guides and fill out the score report. Talk to you later. Bye.